Gentlemen and kind ladies and sirs, dolls and hair monsters amongst you, I give you a Viper 1500 box. I don't know anything about these other than I seen one about 20 years ago. It's a base unit, it's got a transformer in it, it weighs an ass ton, it's got really nice vinyl on it, like legit labels. This is a X-Force cabinet because of the grill slits. I don't know what we're going to find in here. I have a feeling this is a single transistor 4-pil unit, but it is a FZ115 or 1500, so 1500. It's held together with that flat blade technology, which we all know I have such a great affection for it. It's got a beautiful hammer finish on it though. Beautiful gray black hammer finish. But this is a Viper box. It used to be my old CB handle 20 years ago. Way back when I was a young man full of piss and vinegar and life was still interesting and there was new stuff to discover every day. Now I'm just an old bitter crusty fart that likes to stand in his shop and talk to a video camera all day long. So basically, I stand around and I talk to myself all day. It's friggin' awesome sauce, right? You guys seem to enjoy it. You all. So let's dig into the cruxus of this and see what we got going. I freaking love these flat blade screwdrivers. And I understand they make them for Phillips too. I'm sure there's a YouTube viewer out there that's like, hey man, they got that same technology for you in the Phillips world. Okay. We'll go down a size. So we can get a little bit better gription into the oh yeah, oh that's good stuff. Here, okay. You know what? Here, son of a, whoop, whoop. Oh, that's never a good sign when you're all in parts rattling around. The gentleman that owns this says he's never gotten anything more than a couple hours use out of it. And he bought it at a radio break or shootout or something back in Louisiana. And he said he's never gotten any more than a couple hours of use out of it. It was never worth anything. He said it didn't work worth a damn when he bought it. I don't know. Like I said, I've only seen a couple of these over the years, and those were both mobile boxes, and they both ran great, as far as I know. This is the Fat Boy Dave made X-Force copper-clad board build stuff that we see so prolific these days. I can tell you the on-off switch is screwed up, which is no big deal. Wow. We got buckets of bolts on the inside of this. I don't care what it is. My friend that sent this to me almost 2 years ago, I'm going to do him due diligence. It's just the way I am. I am coming to the end of the list, guys. I've got about 15 or 20 amps left that I've got to go through. And then it'll be time for us to start talking about me taking on new work. Now listen, there is going to be some different changes in how to take on new work. We're not doing it like in the past. Oh, here, blindly send me your project. I am asking, and will be asking, everybody to call me on September 1st. And I will give you a number. I'm only going to take on a couple hundred pieces of equipment. I realize the number of pieces of equipment that I can work through and a decent timeline. And I recognize that if I leave the door open blindly like I did last time, I will get 800 pieces of equipment show up here in like 10 days, and then I'm stuck working on that for 2 years. I don't want to have that happen again, so don't send me anything. I'm not ready to take on work yet. I will let you all know through the YouTube channel. Oh boy. Oh, it's a 2 transformer unit. No wonder it's so damn heavy. Oh, look. It's a 6 pill. Got some caps floating around in here, but they're held together with copper bars. Oh, these old rectifiers. Ooh, bad news. Now, either he is working in the most dusty environment known to Jesus and Earth, or this thing's been on for more than a couple hours. It don't matter. We'll make it right. Let's see, we got any smoked 10 ohmers? These all look stock. The one up here's got a modified resistor, so usually what happens, either these output caps go bad or these caps go bad. Now, this splitter board is completely broken off, so that means its input's going to be all over the place. The input here, because these capacitors have to couple to ground. And I now see what was floating around the inside of the cabinet. Remnants of the on-off switch. Alrighty then. Well, let's dig into the meat of it. Okay, so let's look at this like logical human beings. In this note that he sent me, he bought this amp at a break. He doesn't have a lot of history on it. I look in here, and what I see down in here is a lot of transistors that got really hot. I see a lot of parts that might be a little left off. I see 3 different resistors over here on the combiner, all of which they look like they're smoked. And in his note, and then the other thing I see is, let's look at this 10 ohm resistor versus, let's say, those 10 ohm resistors. Okay. These are all 5Ks, and this one's an OG or an 06 is the lot number on that one. So this has been repaired at some point or another. Now, the other thing his note says, as soon as he plugs it in, it blows the fuse. Well, we're going to disregard the effed off power switch over here, and we're going to assume that all that got effed up in shipping. Okay? So it didn't really matter. The $1.50 switch, and that's exactly what it costs because there's a price tag that's on the switch. Let's see. Let me isolate myself here. The $1.50 switch, they soldered the leads for the on-off switch, but they didn't use eyelets. So I just went ahead and I pulled the on wire, just pulled it completely off the switch, and we're going to run this through a variac. Now, I've got this short fuse. Normally you'd want to put like maybe a 15 amp fuse in here. I've got a 5 that's in here. I have a feeling, based off of looking at our rectifier circuit, that there has been some breakdowns at some point or another here. Taking into account that one is different than these other 3. If the rectifying diodes are shorted, it will in turn cause this fuse to get effed off. Now, I don't know if maybe the wires were touching on the $1.50 on-off switch. I don't really know. But what I do know is I hooked it up to my variac. So let's go ahead and we'll probe in here. We'll just hook up here. And we'll probe here. And this is registering DC voltage. Now, if these rectifiers are shorted, we're not going to get very far on turning the old knob here, okay? So let's turn this on. It's fighting me. It's fighting me. And we got no DC voltage on the output side. None. Okay, so instead of blowing the fuse, I mean, we're all watching the same things here, right? Let me show you what I mean. We'll hook onto ground here. We'll switch this over to AC. We'll clip onto it. We're going to clip onto our AC voltage there. Now let me start turning this up. So I'm putting 14 volts AC into this transformer right now. Let's go over here and we'll hook to the output side AC. We walk back around the box again, or the camera. We got nothing coming out. Nothing coming out. Nothing coming out. We'll switch over to DC, the DC side. Got nothing. So either both of these transformers are completely effed off, yeah, fuse is already popped. Okay, well, shit. Let's go find our short. That's AC. Dead short from AC to hot. Dead short from AC to ground. Dead short on hot to ground. And dead short, obviously, we're going to have it on the other side of the transformer as well. So, one of these bridges is flat effed off. One of these rectifiers. Now, I'm not a fan of these 50 volt bullshittiums. They've got tiny little diodes in them, and they capitalize on the heatsink to do most of the work. I'm a fan of these. I like to convert these over to one single rectifier that do the job. One rectifier does the job. We put AC in here, DC comes out here, we attach it to the metal body of the cabinet. Guess what? No more overheat issues, no more problems. So that's problem number one. Once we get the power unfucked, we've got to figure out what we're doing over here on the output side. These transistors have been very, very hot. And I've found if we try to pull any of these, the caps are just going to come flying off there like popcorn. Bink, 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 bink. So unfortunately, the only way that we really get to test these is in circuit. But I can almost guarantee that one of these 3 output capacitors or one of these has gone titties. No good. But first things first, let's fix the DC problem. That sounds lovely, doesn't it? I know it really gets me all turned up, hot, work, and bothered too. I'll let the FLIR boot up here. So I got to thinking, instead of me going through all the hassle of rebuilding the power supply, let's just bypass the power supply and hook it up to the work power supply on the bench here. So I'm using the bench to power the amp section at the moment. Now I've got it set up so it's in operate mode. Still waiting for this turd bucket to boot. Let's go over here. We'll turn on our peak kit. So what radio should I defile this thing with here? We'll put our fingers in her with this. We'll use the bench 2950. Jesus. Viper box, huh? Thermal. Okay. Nothing's hot. Everything's happy. Turn on our 2950. Hey, key relay works. Hello. 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 Input tune is not too bad. All the transistors are getting hot. We got one resistor on the output that is just screaming hot. It's this one here. So we do have an imbalance, which is not a big deal. But we've got all good pills. So what that means is we need to do a power supply rebuild. That's this back has got to get repaired. Either got a shorted transformer, which is possible. I doubt it though, because they stink and they smoke. Definitely needs a new fan. Hold on. Definitely needs a new fan. But let's see if we can beef this up and make this run a little bit better and put some more life back in this guy's box. Now I got answers. Good pills. That's all I needed to know. Just got off the phone with my buddy. This is GoldenRocket's box, by the way, you guys. And I was calling to tell him the joyful news that even though these transistors looked like they're effed off 9 ways from Sunday, that it's going to be okay. That he has no bad transistors. He is a kick in the pants. I hope when I get to be his age that I've got as much life in me as that man has. He is something else. Funny. Oh, loves to laugh. Just loves to laugh. Anywho, back on topic. I am curious, myself, I am curious which one of these 4 little tiny pathetic worthless bridges. Now, I say this because, well, this is what we've got, what they had to work with in the day. This is a 25 amp bridge, and these are 50 amp bridges. And when you cut them apart and sand them down, you find that they have the exact same components in them. These have the same components as this. The only difference is the metal body. Well, we're going to replace these with that. This is the best that they had to work with then, so I can't really judge too bad, right? Okay, so this one is not shorted. So this 25 amp bridge is not shorted. That one is. Yeah, let's see, the diodes are leaking. It should be up around 0.5, 0.3, somewhere in there. But from positive to AC side, dead short. So that's bad. Okay. So go over here, we'll probe on positive. This one's also shorted. And shorted from AC pole to ground. Or no, AC to AC side shorted. So the way this is set up is that there's a diode that goes this way and two diodes that go this way. So there's 2 and 2. It's a diamond formation, right? So actually it's set like that. All the anodes face this direction. So you come between the anode and the cathode and the anode and the cathode here, and that's where you inject your AC. So across the AC poles, it's dead shorted, right? Then from AC to ground, and then from ground to hot, we're going to have a little bit of leakage because we have short from here to here. It doesn't matter how we do it. Short. So that one's popped. And then we'll go and we'll look at this here. We'll go from AC to positive. Of course, positive is the one that's got the cant to it. You'll notice that all of these are faced the same way. This one's got a cant to it. That's your positive leg, of course. So then you know opposite of that pole is going to be ground, and these are going to be your 2 AC leads. And all you need to know is it's either got a cut in the tab or that the tab is faced the one direction. And you know for a fact, just by looking at this, you can go, oh, look, it's got a cut tab on it. I know that this is going to be my positive. On all bridge rectifiers, it's the same way. It's called a standard, right? So if we go and we look at this, not only is it printed positive, negative, or positive AC, the tab is orientated differently. So we know that this is our positive, and over here is going to be our ground, and this is going to be our AC side. So let's see if we can find any shorts in this one. But those are our problems. Okay. Yeah. I'll flip it around. We'll see if the pixies leak through the diode the other direction. They do. So this is good. These two are good. These two are bad. The problem I have found with those is they just don't work very well. Guys built with those for a lot of years because that's the best technology that they had. It really is a submerged diode. The idea is that the diode gets hot, it lets the heat get wicked into this polymer that's in here, and then the heat gets wicked to the case, and then the case carries it away to a heat sink, and then the heat sink dissipates the heat. Well, it's the best they had in the day. Now we're going to file that in a bucket, and we're going to upgrade it to a little bit more heavy technology. So 1,600 volt, 200 amp continuous duty cycle diode. Now, I probably wouldn't use this for anything more than about maybe, I mean, literally it's 200 amp, 1,600 volt. Remember, Chinesian product. So we're not going to use, I mean, we're going to probably pull 180 amps through this diode bridge, but the voltage is way low. Winning. And here it's the same thing, but much bigger diodes with much more heatsink surface area. So which do you think is going to have a prayer of lasting? 50 amp, 25 amp. It's actually supposed to be all 50 amps. And you know, I could be wrong. They did make 50 amps in this case style, they just weren't as common. This is primarily a 50 amper here. So which do you think is going to last longer? These 4 little tiny bridges or one big horse penis? Throw them away too because I don't reuse those for anything. And I don't need any of that. We'll throw all that away. Okay. So we've got this stripped down a little bit now. So I'm going to build me a little stand, put the heat sink on. We're going to reuse this heat sink. We're going to mount this to the heat sink, and then we're going to make it so that this is floating up here above everything because, well, let's face it, our footprint is so massive. What I would normally do is I would take one of the filter caps and I would move it over and I'd mount it right here, or I'd mount it to the front of the amp and let the case do the job. This thing is completely painted, so we're not going to be able to do that. I'm going to have to get a little bit creative, but for my buddy Rocket, I'm willing to do it. He sent this to me nearly 2 years ago, boys and girls, and he has been the most patient customer. He would call me about once every 6 months and say, "Hey BBI, where are we at?" And I'd be like, "Man," and I know I'd come across as like he was annoying me, but he was not annoying me. It was, I felt bad that I couldn't get to more of these projects quicker. And I'd be like, "Man, I'm sorry. I'm working that way. I'm trying." I'm just glad we're finally here. I pulled all this junk power wire out of here. We're going to replace all this junk power wire. And now that you guys have seen it on video, instead of me having to look at it, come here, come on. We're going to file that in a fuck it bucket too. Goodbye. All right. This thing needs a bath in the most desperate way ever. I pulled the broken switches off the front. Now, what I want to know is, this is like a old Fat Boy box, or not Fat Boy, but X-Force, like oods of X-Force opulence. But I think that this is stamped out of steel, because this is all corroded. And I don't know. There's a couple other things in here that we're going to go and change, like we're going to completely, like, we'll get rid of this glob of solder, which is actually buried in hot glue. We're going to rebuild our combiner, we're going to redo our inductor. We're going to get rid of this doorknob and this other flaky ass bullshit that's going on here. We'll probably put a tuning capacitance tube in here. Of course, we're going to give him the whole 5-watt resistor, power wire upgrades. We're going to do metal-clad capacitors on the top of the output transformers, and we're going to replace these Mylar caps with metal clads. Because I don't want him to ever have another problem with this ever as long as he's alive. I want him to be able to plug this in, turn it on, and go. But first, before I can start any of that BS, I've got to wash it, wire up new power switches, put a brand new LED in the front of this. You guys can't see it, but this is bent right here, and that's the way it came to me in shipping. I don't know quite how I'm going to repair this quite yet. I might have to sand this back and then tape this off and then paint this, and then we'll have to do him a new label for on-off. But he's going to get a new fan. Yeah. I sent him pictures of this. 84-year-old man texts me back. Your pictures won't download. I don't know what's going on. Maybe my data is not on my phone. Had me dying that he even knew what the hell was going on. I was like, wow, this guy is badass. So, Golden Rocket, this one's for you, bro. How about now you guys are like, what the hell, BBI? This is not what you told us you were going to do. And you're right. So the electrolytics are being held in by just the thought and the whisper of glue. And that's flexing around like crazy. And I didn't like the idea of this bullshit. So when I had to pull all the caps out because I had to test them anyhow, I got to make sure they're worth a shit, right? They all test okay. That's not a big deal. I've still got to fix this. That's all effed off. But I'm like, I got to get all the old glue off so I can re-put these back in. And I thought, what happens if I slide these over like so, and then slide this over like so? Instead of having them, they were stacked up like this. Right? So what if I slide this down, and then I get this nice big flat space down here that I can have bare metal on. I'm going to take the rectifier bridge and put it down here out of the way. So I can bring all the AC to here, bring out full up chooch DC, have my on-off switch, it's not going to get in the way, have my filtering cap, not get in the way. I got a nice good clean path for air right down the middle of the two transformers. I'm going to fold right down through here and exhaust out the cabinet. I was like, that's what I'm doing. So, got out the wire brush, took some time, cleaned all the old hot glue. Not like E600 or E6000 glue or anything. Hot glue. I was holding the old caps down. Sanded down to bare metal here, or wire brush down to bare metal. So now we'll use the whole cabinet as a heat sink, the diode bridge. We will get rid of the air restriction from the fan. So we're going to have good airflow coming in. That also gives us the opportunity to add a screw and a nut to go down through here to hold this in place. So this thing doesn't beat itself to death like it's done in the past. And we're going to make the best out of all in all worst situation, in my opinion. Well, I have officially spent more time repairing this thing than I think what they spent building it. Let's unplug that for a moment. These transistors have been hot. So, power supply is completely renovated and is now fully functional. I'll show you that here in a minute. These old burn up solder joints. I mean, this is a testament to how rough, true, tried, and tested the Toshiba is. Toshiba 2879. This thing has been overvolted. These transistors have been overvolted their entire lives. They've been put on just barely enough heatsink. This amp didn't have a big enough fan on it. It does now, though. And those transistors were cooking themselves to death. So I'm sure that these caps are still 100% good, but I mean, what's $60 worth of parts amongst friends? Just saying. I'll replace these with metal clads, that way I know I can sleep at night. Is it going to help it do any more wattage? No, not at all. Is it going to make me feel better? And me alone? Because I know this guy. He's an old-time CBer. He don't give a shit. He just wants the watts. Is he going to give a crap about if it's got high-dollar parts in it or if it just works? No, he's not going to care. But it makes me feel better. It really does. So, therefore, it's worth it. Ya-da-da, da-da-da-da. Ya-da-da-da, da-da-da-da. So, I'm working along, and I keep turning this thing upside down to knock more crud out of it. And, you know, just the weirdest thing happened. Let's see. This 1000 UF 16 volt electrolytic comes tumbling out of it. I don't know. I know this. I can tell there's been some pigs in the pie here over the years. You know what I'm saying? So I can't really point my finger at the last guy or the previous 5 people that have owned this thing. Man, every once in a while I'll come along, I'll solder on something on this box, it just reeks of cat piss. I don't want to think anything more about it than that. I just don't. I really don't. Throw these up here in a corner. Okay, I made you guys wait long enough. Okay, so that you know, these APC battery backup transformers, that's what these come out of, is APC battery backups. The old ones, not the current ones. The current ones are, well, they have switch modules in them that suck, and they're really loud, electrically loud, but for a long time they had these New Mexico transformers in here. These are 75 amp a piece, roughly. So they say, 50 amp, whatever. Hey, it helps we got it plugged in, yo. There is a high and a low tap on these. And this is obviously wired high tap. So we're floating at 20-something volts. Without the little tiny parasitic draw of the 24-volt fan that we put on here, which is a huge upgrade to the dirt-filled turd bucket that was on here. This is floating at like 21, 22 volts. So now this isn't a regulated fan, this little guy here. This is an MMB. It's a high flow fan. When we key, this fan will slow down. It's going to go, modulate your key. It's okay. This is going to provide enough air to actually cool this thing. I've thrown the lid on it. I've measured the velocity coming out of the cabinet. It's tested. It's tested. Now, since we don't commonly employ bleeder resistors or bleeder circuits in these 12-volt supplies, the fan spooling down kind of acts as the bleeder, and then eventually the resistance, the electrical resistance, the cap takes over that, and the LED is constantly pulling. Put a brand new LED in it for you, brand new on-off switch, brand new operate standby switch, and wired all those appropriate things up. So the only thing I really got left I need to do here is test these 3 caps, make sure they're still good, replace these 3 caps, replace these 6 resistors, replace these 3 caps, and let's rework this horsefuckery here in the corner. Well, okay, so these are our output caps, and these are our 1,000 puffers that were over our transformers. Remember how I said a couple segments ago, pardon me, that the biggest flaw in these 6 pillboxes is using these Mylar caps as a final tune? These mother effers get hot and they devaluate themselves. So all 3 of these are the same thing. Focus camera, please. It's 150, 500 volt, 5% capacitor. So we're going to put this on our capacitance meter and we're going to check out what it's doing here. This one reads 14 puff instead of 150. That is what's controlling the tune of each one of these sections. So it's only 135 picofarads off from what it's supposed to be. This one here, 148.3, 148.1. Okay, that's within spec. This one here, 114.1. So we have one that is 45 puff out and another one that's 140 something or 130 something puff out. There's a reason that every one of these that come in here I replace them with a metal clad. Now the same thing can happen with these 2 500 volt caps. It's not quite as a same common problem, but it is still totally possible. So that one reads within spec. Okay, so 672. And this is supposedly 2 500 volt or 500 puff 5% caps. So between the output tune capacitors and the swamping capacitors all being out of whack, I can see why this was giving my homie Golden Rocket a hard time. See, this one's way out of spec too. 737, and this should be 1,000 right here. So that's 250, 300 out, and actually or 300 out and within spec. Needless to say, all of these get filed in the fuck it bucket as well. That would probably account for 90% of the problems. Those 4 caps will account for 90% of the problems of this whole box. Well, that and the bridge rectifiers being a bag of dicks. This old beat down bag of dick is this thing works good for what it is. Old girl with a bunch of new parts in it, but I mean, it works really good. Let's go ahead, we'll turn on the power supply. I'll just spray some clear spooge in here and make it so it stays this way. Nice forever, you know what I mean? Alright, let's go over here real quick. It's a 1,000 watt element in 2X, so when we reach full deflection over here to the right, that's 2,000 watts. It's 1,000 in average. 5 watt slug in reverse back from the bird, 10,000 watt dummy load. This here is our voltage on the inside of the power supply. That currently says 21 point, okay, I lied, 20.99. And put the amp in standby for a moment so I can show you drive. Remember, this is on the 2x scale. Hello, 1, 2, 1, 2, 1, 2. Turn my monitoring radio down. I do that with all bass units because I want to make sure I don't have any hum in my audio. Actually, hold on a second. Let me go over here. We'll plug the bass radio into the gate system. So under that old Model T, was the place she first showed it to me. It was big and black and she called it her crack. Alright. So zoom in here. This is what we're doing for radio drive. Hello, 1, 2. It's just short of 200 watts, like 180 watts on that scale. Let's go back down to 1x so it all makes sense to everybody. Hello. About 125 watts worth of drive going into a straight 6. Turn the amp on. Hello. 1, 2, 1, 2, 1, 2. 1700 and change. Hello. If I really yarp in the thing, it gets over there.
Was the place she first showed it to me. It was big and black and she called it her crack, but it looked like a manhole to me. So I pulled out my old top hole and I stuck it in her black manhole. As she began to scream, I poured on that cream in the color of that old Model T. Hello, 111111.
Okay, now I can't get too carried away because I don't have a lid on the inside on this thing, so there's no airflow. Let's look at the power supply. Hello, 1, 2. Staying steady right at about 15.5 volts. So we're seeing a 5-volt drop, and we can hear that corresponding with the fans as well. So, needless to say, I think this thing is good to go. Okay, let's go look at the input swirls here. We'll zip on up here. Take a hot minute. We're going to look at this bird meter here. Right there. Hello, 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 hello. Hello, 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 hello. Hello, hello. Hello, hello. As we can clearly see, Striker's happy, bird meter's happy, everybody's happy. So, that translates to, hello, kick ass and take names. Hello, 1, 2, 1, 2, 1, 2, 1, 2. Mr. Golden Rocket, I gotta tell you, buddy, I appreciate you waiting as long as you did. I want to thank you for your patience, and I hope you have a lot of fun using this down there, tearing up the locals with it. Because all them boys down there, they deserve it. I wanted to originally call my first run of boxes, I want to call them Viper boxes, because that was my handle. And then I very quickly found out that there was already a guy out there building Viper boxes, which I did not know. I hadn't built one box yet, but the naysayers jumped on me pretty quick. You're never going to get that done anyhow, so don't worry about it. Blah, 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 blah. I'm here to tell you, 10, 11, 12 years later, 10 years later, I'm still here. This cat's gone. And we're over having fun on the YouTube channel. This is a very well put together box for what it was in its day. I cannot take this as a complete judgment on this gentleman's handcrafted craftsmanship. I cannot. There's been too many fingers in the pie here over the years. All I know is that the key-in capacitor was 50 and not 10. And on top of the myriad of other shit that we found inside of here. It's got good parts. It was in a fairly well decent cabinet. Yes, this is made of tin that's been spray painted. The lid is an X-Force lid, and we know that because of the notch cuts in the corner. It's either a Fat Boy or X-Force lid. Or not Fat Boy, pardon me, Dave made her X-Force lid, but for the most part, in its day, it's not bad of an amp. Well, the only thing I'm going to do to it tomorrow before I send it out of here is I'm going to put a PIM nut in this hole, because you can see that, well, not, I'm going to use a crush nut. We can see the PIM nut's been knocked out of here, so. But it came in here completely unfunctional and is leaving here in way better shape than when it came in. And it looks like new on the inside, so F it. We'll take it and smile. Golden Rocket, homie, appreciate you, buddy. All you gentlemen out there in YouTube land, I want to say thank you for all your support. Like I said, I will be starting to take on new work in September, which will just be repairs. Do not send me your equipment in the blind. You must call me first, and you have to get an RA number. The repair order numbers will be secret. They have to be on the outside of the box. Otherwise, your equipment will be returned to you. So believe me, there's more on that to come in the next couple months. Between now and then, I'm just going to focus down and do repairs. So, gentlemen, I appreciate you. I'll see you. Click, click.